Hey, what's going on, everybody? Today we're diving into something that most mechanics won't even tell you about because honestly, a lot of them don't even know to look for it. We're talking about how your engine mounts, yeah, those rubber and metal chunks that hold your engine in place, are secretly destroying your suspension alignment. And I'm not talking about the obvious stuff like when your whole engine is visibly sagging. No, these are the sneaky hidden issues that are wrecking your alignment, eating your tires, and making your car handle like garbage, and you have no idea it's happening. Before we get into it, do me a huge favor and smash that subscribe button right now because we're dropping knowledge on this channel that will literally save you thousands of dollars in repairs, and I don't want you to miss a single video. Alright, let's get right into it. So the first hidden issue we need to talk about is asymmetrical engine mount collapse. Now listen, most people think that when engine mounts go bad, they all wear out evenly at the same rate. Wrong, dead wrong. What actually happens in the real world is that one mount, usually the driver's side or the torque mount, starts failing way before the others. And here's why this is absolutely destroying your alignment. When that one mount collapses even just a few millimeters more than the others, your entire engine mass shifts in one direction. We're talking about anywhere from 300 to over 600 pounds of weight that's now sitting off center in your engine bay. Your suspension was engineered with the assumption that this mass would be perfectly centered and stable. When it shifts even slightly, it creates an uneven load distribution across your front suspension components. The side with the collapsed mount now has more weight pushing down on it, which compresses that side suspension more than the other. This causes your camber angles to go out of spec, your caster to become uneven side to side, and it creates a rolling difference in how your suspension geometry operates. You can get an alignment done every month and it still won't fix the problem because the root cause is that shifted engine mass. The alignment shop is just setting your angles based on a false baseline with that heavy engine sitting crooked. As soon as you drive away, the dynamic forces of acceleration and braking make that crooked engine rock and shift, and boom, your alignment is already getting pulled out of spec again. I've seen this exact issue cause cars to eat through a set of front tires in less than 15,000 miles, and the owner kept blaming the alignment shop when the real culprit was a $60 engine mount that had collapsed on one side. The second hidden destroyer is what I call rotational mount degradation, and this one is seriously insidious. Engine mounts aren't just solid chunks of rubber, right? They're engineered with specific durometer ratings and sometimes even hydraulic fluid chambers that are designed to absorb vibrations in specific directions. When these mounts age, they don't just get softer overall. What happens is the rubber develops internal shearing and separation that you can't see from the outside. The mount might look perfectly fine, no visible cracks, no obvious sagging, but internally the rubber has separated from the metal bonding plates or the internal structure has degraded. This creates what engineers call compliance variation. Basically, the mount becomes way softer in rotational movement than it should be. Why does this matter for your alignment? Because every time you accelerate or decelerate, your engine is trying to rotate on its mounts due to torque reaction. Normal healthy mounts resist this rotation within a very tight range, maybe just a few degrees of movement. But when you've got this internal degradation, your engine is now rotating 5, 10, even 15 degrees under normal driving conditions. This constant rotation creates a cyclical loading pattern on your suspension. When you're on the gas, the engine torques one direction and loads up one side of your suspension. When you let off or brake, it torques the other way and loads the opposite side. This back and forth cycle is constantly flexing your suspension components and control arms in ways they were never designed to handle. Your ball joints, tie rods, and control arm bushings are now dealing with these weird lateral and torsional forces that are coming from engine rotation instead of just normal road forces. Over time, this accelerated wear on your suspension components causes them to develop play and looseness, which, you guessed it, makes it impossible to hold in alignment. I've diagnosed cars that had brand new alignment settings that were perfect on the rack, but the moment you drove the car and put it under load, the worn suspension components would shift from all that engine rotation abuse, and the alignment would be completely different. The technician is sitting there scratching his head wondering why the alignment won't hold, and it's because nobody checked for excessive engine rotation caused by internally degraded mounts. Now let's talk about the third issue, and this is frequency resonance misalignment. This one sounds super technical, but stay with me because it's actually pretty simple once you understand it. Every suspension system has what's called a natural frequency, which is basically the rate at which it wants to oscillate or bounce when it hits bumps. Engineers spend tons of time tuning this frequency with spring rates, damper valving, and bushing compliance to give you a smooth ride and good handling. Your engine mounts are also part of this equation. They're designed to isolate engine vibrations at specific frequencies, usually in the range of about 20 to 40 Hz depending on your engine's idle and running characteristics. Here's where it gets nasty. When engine mounts start to fail and their stiffness changes, they no longer isolate vibrations at the correct frequency. Instead of absorbing engine shake, they start transmitting it directly into the chassis and suspension. But even worse, when the mount stiffness changes, it can actually create a resonance condition where the engine vibration frequency matches or gets really close to the suspension's natural frequency. When this happens, you get what's called sympathetic resonance, where the vibrations amplify each other instead of canceling out. This creates a situation where your suspension is constantly oscillating and vibrating at a frequency that prevents it from settling into its design geometry. Think of it like trying to balance on one foot while someone's shaking the floor. You're constantly making micro adjustments and you can never quite settle into perfect balance. That's what's happening to your suspension alignment. The geometry is constantly shifting and oscillating because of this resonance from bad engine mounts. Your alignment angles are literally changing dozens of times per second as the suspension vibrates. The average values might still measure okay on an alignment rack when the car is static and the engine is off, but in real-world driving conditions, your suspension is never actually at those specified angles. It's constantly oscillating around them. This causes uneven tire wear patterns. Usually you'll see feathering or cupping, and it makes the car feel nervous and unsettled over rough roads. The fix is replacing the mounts to restore proper frequency isolation. But most mechanics will never even consider this because they're not thinking about the dynamic relationship between engine mounts and suspension behavior. The fourth hidden issue is something I call thermal expansion differential, and this one is particularly bad on cars with transverse mounted engines, so basically most front-wheel drive and a lot of modern all-wheel drive vehicles. Here's what happens. Engine mounts are made of rubber compounds that have a pretty significant thermal expansion coefficient. That means when they get hot, they expand and get softer, and when they're cold, they contract and get stiffer. In a perfect world with brand new mounts, all of the mounts would heat up and cool down at the same rate and maintain their relative properties to each other. But in reality, the mounts are in different positions around the engine. The lower mount might be right next to the exhaust manifold getting blasted with heat. The upper torque mount might be up in the airflow where it stays relatively cool. The side mounts might be partially shielded by heat shields or exposed to road spray that cools them down. As these mounts age and as people run different coolant temperatures or have cooling system issues, the mounts start to age at different rates based on their thermal exposure. The mount that runs hotter deteriorates faster and becomes softer. The cooler mount stays relatively firm longer. Now you've got mismatched mount stiffness, but here's the kicker: it changes based on temperature conditions. Your car might drive relatively normal when it's cold, but after 20 minutes of driving when everything is heat-soaked, suddenly one mount is way softer than the others and your engine position shifts. This shift changes your suspension loading and geometry. I've seen cars that would pull to the left when cold and pull to the right when fully warmed up, and it was entirely due to differential thermal expansion of worn engine mounts changing the engine position. Your alignment is actually different when the car is hot versus cold, and no alignment machine will ever catch this because they're measuring the car static in the shop. Out on the road under real thermal conditions, your suspension geometry is shifting around as those mounts heat up and change stiffness. This also creates a really confusing diagnostic situation because the problem is intermittent and temperature dependent. You take it to the shop, they check it cold, everything looks fine. By the time it's your turn for a test drive, things have cooled down again and the problem isn't as noticeable. Meanwhile, you're out there driving every day dealing with this weird shifting alignment that seems to have a mind of its own. The fifth and final hidden issue is subframe micromigration, and this is probably the most damaging one of all because it can actually cause permanent changes to your chassis. Here's how this works. On most modern cars, the engine doesn't mount directly to the main chassis structure. Instead, it mounts to a subframe, which is basically a separate frame assembly that then bolts to the main chassis. Subframe also holds your front suspension components, your lower control arms, your steering rack, basically everything that matters for your front end alignment. The subframe is held to the chassis with big bolts and usually some bushings to isolate noise and vibration. Now the engine mounts connect the engine to the subframe. When your engine mounts are healthy and doing their job, the engine stays put and all the forces from acceleration, braking, and engine torque are properly absorbed by the mounts. But when the mounts start failing, those forces don't just disappear. They get transmitted through the degraded mounts into the subframe itself. We're talking about massive forces here. Every time you accelerate hard, your engine is trying to twist with hundreds of foot-pounds of torque. Every time you brake, that whole engine mass is trying to shift forward. When the mounts can't control these forces anymore, the subframe itself starts to move and shift. We're not talking about big, obvious movements. We're talking about micromigrations, tiny shifts measured in tenths of a millimeter. But here's the problem. Every time that subframe shifts even a microscopic amount, it's wearing against its mounting points and bushings. Over thousands of miles and thousands of acceleration and braking cycles, those tiny movements add up. The subframe mounting holes in the chassis can actually become elongated. The subframe bushings develop play and wear unevenly. Eventually, the subframe isn't sitting in exactly the same position it was when the car was new. Maybe it's shifted back 2 millimeters on one side and 1 millimeter on the other. Maybe it's rotated slightly. These tiny changes completely throw off your suspension geometry because remember, all your suspension mounting points are on that subframe. If the subframe has migrated even slightly, your control arms are now at different angles, your steering rack is in a different position, and your entire front suspension geometry is operating from a shifted baseline. Here's the really nasty part. Once this subframe migration happens, even if you replace the engine mounts, the damage is already done. You now have a chassis with elongated mounting holes or worn bushings, and the subframe might not even be possible to get back to its original position without major work. I've seen cases where this required drilling out the subframe mounting points and installing oversized bolts or even welding in repair plates to relocate the mounting points. This is a situation where a couple $100 in engine mounts that should have been replaced could have prevented thousands of dollars in chassis repair work. And the worst part is, most alignment shops will never even check for this. They'll just keep trying to align your car within whatever limited range of adjustment you have left, never realizing that your entire subframe is sitting crooked in the chassis because failed engine mounts allowed it to migrate over time. So now that you understand these 5 hidden ways that engine mounts are absolutely destroying your suspension alignment, let's talk about what you need to do about it right now. First thing, if your car has over 60,000 miles and you've never replaced the engine mounts, there's a very high probability that you have at least some level of degradation in multiple mounts even if you can't see it or feel it. This is especially true if you live in an area with temperature extremes, lots of stop-and-go driving, or if you've ever had any engine work done that required jacking up the engine, because that can pre-stress and damage mounts. Get under your car and do a visual inspection of every mount. Look for obvious cracks, separation of rubber from metal, fluid leaks if you have hydraulic mounts, or any visible sagging. But here's the key: even if they look fine, you need to do a dynamic test. Have someone rock the engine back and forth with a pry bar while you watch the mounts. You should see the rubber compress and flex, but you should not see the metal parts of the mount contacting each other or moving excessively. If you can see metal-to-metal contact, or if the engine moves more than about half an inch in any direction, your mounts are toast. Next, check for the asymmetric wear pattern I talked about. Measure how much each mount allows the engine to move. If one mount lets the engine move noticeably more than the others, you've got the asymmetrical collapse issue. Now here's my recommendation. If you're having any kind of alignment problems, weird tire wear, the car pulls differently when accelerating versus coasting, or you just can't seem to get an alignment to hold, replace all of your engine mounts as a set before you spend another dime on suspension or alignment work. I know it seems expensive and I know it seems unrelated, but trust me, I have seen this exact situation play out hundreds of times where people spent thousands on suspension parts and multiple alignments trying to fix a problem that was caused by $150 worth of engine mounts the whole time. When you do replace the mounts, here's some critical things you need to know. First, do not cheap out on parts. I know there's mounts on Amazon for like $20 each and the OEM ones are $80 or $100. Buy the good ones. Those cheap aftermarket mounts use inferior rubber compounds that will fail again in half the time, and some of them are manufactured with incorrect stiffness specs, which means they won't control engine movement properly even when new. Second, make sure you get the engine properly supported and positioned when you're installing new mounts. If you just jack up the engine randomly and bolt in new mounts, you might be locking the engine in a tilted or shifted position, which means you're not actually fixing the problem. The engine needs to be at its proper ride height and centered in the engine bay when you torque down the new mount bolts. Most factory service manuals have a specific procedure for this, usually involving supporting the engine at certain points and removing all the old mounts before installing new ones so the engine settles into its natural position. Third, after you install new mounts, give it about 100 miles for everything to settle and seat properly, then go get an alignment. The alignment shop needs to know that you just did engine mounts so they understand they're working with a new baseline. If you've been fighting alignment issues for a while, there's a good chance you also have some worn suspension components from all the abuse those bad engine mounts were causing, so have the shop do a really thorough inspection of ball joints, tie rod ends, and control arm bushings while they've got it on the rack. One more thing I want to mention because I know someone's going to ask, what about upgraded or performance mounts? Should you go stiffer? Here's my take. If you're driving a stock daily driver, stick with OEM spec mounts. They're engineered specifically for your car's weight, power output, and suspension tuning. If you have a modified car with significantly more power or you do track days, then yeah, upgraded mounts can help control engine movement better, but understand the trade-off. Stiffer mounts transmit more vibration and noise into the cabin. You'll feel more of the engine's character, which some people love and some people hate. More importantly for this discussion, if you go too stiff on the mounts, you can actually create new problems where the engine doesn't have enough compliance and starts transmitting shock loads into the chassis and suspension during hard acceleration or if you hit a big bump. There's a sweet spot. And for most people, that sweet spot is OEM or maybe a slightly upgraded mount that's only about 20 to 30% stiffer than stock. Anything beyond that, and you're getting into race car territory where you're accepting more vibration and harshness for the benefit of better control. Here's the bottom line. Your engine mounts are not just about preventing vibration and keeping your engine from falling out of the car. They are a critical part of your suspension system's ability to maintain proper geometry and alignment. When they fail, especially when they fail unevenly or in these hidden ways we've talked about, they can cause damage that cascades through your entire front end. You end up chasing alignment problems, replacing tires prematurely, replacing suspension components that wore out from abnormal loading, and possibly even damaging your chassis structure with subframe migration. All of this can be prevented by paying attention to your engine mounts and replacing them before they get to the point where they're causing these problems. This is one of those maintenance items that nobody thinks about until something goes really wrong. But if you're proactive about it, you can save yourself a massive amount of money and frustration. If you got value from this video, make sure you're subscribed because we're going to keep bringing you this kind of real-world diagnostic information that actually helps you fix your car instead of just throwing parts at problems. Drop a comment and let me know if you've ever dealt with any of these engine mount issues. I want to hear your stories. And if this video helped you figure out what's been going on with your car, let me know that too because that's what this is all about. Alright, that's it for today. I'll catch you in the next one. Before you go though, I want to dive just a little bit deeper into some of the diagnostic tools and techniques that can really help you identify these problems early, because prevention is always cheaper than cure. One thing a lot of people don't realize is that you can actually use your smartphone to check for engine mount issues. There are apps out there that measure vibration frequency, and if you place your phone on different parts of your engine bay while the car is idling, you can get a sense of how much vibration is being transmitted through the mounts into the chassis. If you're seeing significantly higher vibration levels than you would on a similar car with healthy mounts, that's a red flag that your mounts are not isolating vibrations properly. It's not a perfect diagnostic tool by any means, but it's something you can do right now in your driveway that costs you nothing. Another thing you can do is pay attention to the noises your car makes. When engine mounts start degrading, you'll often hear a subtle clunking sound when you shift from drive to reverse or when you accelerate hard from a stop. That clunk is the engine moving more than it should be and hitting the limit of its range of motion. Some people describe it as a dull thud, others say it sounds like something loose under the hood. If you're hearing these noises and you can't find anything obviously wrong, engine mounts should be near the top of your diagnostic list. You can also pay attention to how your car handles over speed bumps and rough roads. If your suspension feels nervous and oscillates more than it should, especially if this seems worse after the engine has been running for a while and everything is hot, that's consistent with some of the frequency resonance and thermal expansion issues we talked about. Your car's suspension should feel planted and controlled, not like it's bouncing and wavering around. Now I also want to talk about the relationship between engine mounts and other components that often get replaced unnecessarily. How many times have you heard about someone spending $800 on a new steering rack or $2,000 on a full suspension overhaul when the real problem was something simple like engine mounts? This happens constantly because most shops don't think to check the mounts first. They see alignment problems and worn tires and they assume it's a suspension issue, but they're not considering that the root cause might be upstream in the engine mounting system. This is why I always recommend getting a second opinion if someone is quoting you a big repair bill for suspension work. Ask them specifically if they've checked the engine mounts. Ask them to show you the results of their dynamic mount testing. If they haven't checked, that should tell you something. A good technician is going to check the basics first before recommending expensive repairs. Engine mounts are basic. They're fundamental to how your car's suspension operates. If you haven't checked them, you're shooting in the dark. I also want to mention that if you drive a lot in very hot climates or if you tow heavy loads frequently, your engine mounts are going to age faster than someone who drives in moderate conditions. The constant heat stress and the additional loads on the mounts from towing accelerate the wear process. If this describes your situation, you might want to consider replacing engine mounts more frequently than the typical recommendation. Some manufacturers recommend checking them every 30,000 miles if you tow, instead of waiting until 60,000 miles. It's not a huge expense when you're being proactive, but it can save you from the nightmare of dealing with the cascade of problems we've discussed. Another aspect I want to touch on is the difference between OEM mounts and quality aftermarket mounts. I mentioned this briefly before, but it's worth expanding on because there's a huge range of quality out there. OEM mounts, the ones made by the car manufacturer, are engineered with specific durometer ratings, specific stiffness levels, and specific damping characteristics that match your car's suspension tuning and engine characteristics. They're expensive because they're designed precisely for your vehicle. Quality aftermarket manufacturers like Energy Suspension, Prothene, or Vibrate Technics spend time and money engineering their products to match OEM specifications, and often they'll exceed them. Their mounts are quality products made from better materials that last longer. Then you've got the bottom-tier aftermarket stuff, the imports from overseas, the super cheap Amazon specials. These are often made with incorrect stiffness specifications, inconsistent quality control, and inferior rubber compounds. Buying one of these mounts to save $40 is like skipping an oil change to save $5. It's penny wise and pound foolish. When you're doing this repair, spend the money on quality parts. You're going to be living with these mounts for the next 50,000 or 100,000 miles. You want them to be good ones. Along those lines, I want to talk about the labor cost aspect of this repair because that's often what scares people away from doing it. Depending on how many mounts your car has and how they're positioned, this job can take anywhere from 1 hour for a simple mount replacement to 6 or 8 hours if multiple mounts are in tight spaces or if you have to remove other components to get access. For a transverse-mounted engine with multiple mounts in tight locations, you might be looking at a full day of labor. That's going to add up. But here's the perspective I want you to have. If you ignore bad mounts and they cause the problems we've talked about, you could end up spending thousands on suspension repairs, alignment work, premature tire replacement, and potentially chassis damage. A few $100s in labor today is absolutely worth it to prevent those costs tomorrow. This is also a good time to mention that if you find yourself needing engine mount work, you might want to get other wear items inspected while the engine is lifted. Things like engine seals that might be weeping, spark plugs if they're due for replacement, or cooling system hoses that might be getting brittle from age. You've got the engine up anyway, might as well get maximum value from that labor. Finally, I want to emphasize that engine mounts are something you should be checking proactively as part of your regular maintenance routine. Every time you're under the car doing other work, take 30 seconds and look at those mounts. Are they still looking healthy? Is the rubber still dark and pliable, or is it starting to crack and harden? Is there any evidence of leakage from hydraulic mounts? By catching problems early, you avoid all of the downstream issues that we've discussed throughout this entire video. You keep your suspension geometry stable, your tire wear even, and your chassis structure intact. You save yourself thousands of dollars and countless hours of frustration trying to figure out what's wrong with your car. That's really the message here. Engine mounts are small, relatively inexpensive components that often get overlooked because they're out of sight and most people don't think about them. But they are absolutely critical to how your suspension performs. Treat them with the respect they deserve and your car will reward you with better handling, better tire wear, better alignment stability, and a much longer life overall.